Assalamu alaikum and welcome to you all for this video, which is about the revision of what we have done in the class so far. It is basically about the error and root finding problem. Just to remind you that we will be follow numerical analysis by Burden Fairs and reference books are numerical method for engineers and advanced engineering mathematics, which are easily available on the net. So let's start. In this video, we'll be covering errors, root finding problems, and root finding method, and then I will give application of these methods to some engineering problems. So, error. As I have told you that I am just revising this lecture, and most of these terminologies are already defined in the class. So I will quickly go through these slides. So first, three definition means error, true error, absolute error, and percentage relative error are defined like this. As most of the methods are iterative methods, so in case of iterative method, we can calculate EA, approximation error, using the current and the previous values, and formula is similar to the relative error, but it uses current approximation and the previous approximation. Our methods will be iterative, and for iterative methods, it is important to give a stopping criteria. Stopping criteria means when the error in the iteration is less than a tolerance value. The tolerance value is defined in the literature, and for the significant digits, we have this expression. This means that if we want to increase the significant digit or the accuracy, we need to do more calculation, as with the increase by the increasing value of k, tolerance value will decrease, and we have to minimize our error, and we have to set this error less than the tolerance value. So these are the important thing when we will be using the methods for finding different calculation like root finding problem, interpolation, and all other things in the course. Major part of these slides are root finding problem and root finding method. Root finding problem is a problem in which you are given with a function f of x and you want to find a value p where this function is equal to 0. So such problem where you are given with a function and you want to find the value p where the function is equal to 0 is called the root finding problem. There are different methods in literature: analytical method, graphical method, and numerical method. As this course is about the numerical method, so we will be studying these method. There are different method available, but our focus will be on the first four in the list: bisection method, Newton's method, secant method, and false position method. Some methods are bracketing method and some methods are open method. So in the next slide, I will explain what is a bracketing method. In a bracketing method, we initially choose an interval which contains the root, and then we develop the procedure to make this interval smaller and smaller, but we have guarantee that this smaller interval also contains the root. Example of bracketing method are bisection method and false position method. Open method are the one in which we use the initial guess and then we don't know where will our solution, uh, where we can find our solution. So these methods are generally more efficient, but they have problems regarding their convergence. So now we will give some detail of these methods one by one. First of all, bisection method. In bisection method, we are given with a function f of x and interval. Sometimes we find the interval and sometimes the interval is given. Hmm, we can find the interval. We can find two such values of the interval where at the end point, the product of the values of the function is less than 0. Means on these endpoints, a and b, the value, the function value must have opposite sign. So if this is the criteria, then we can start our method. And what is the method? Method says that we need to find a middle point value. This midpoint value denoted by C is the value obtained by adding A and B and dividing by 2, and then we calculate f of C. After calculating f of C, we will check whether this value has opposite sign to f of A. If this is the case, means f of A and f of C has opposite sign, then the root will lie between A and C. But if this is not the case, means f of A and f of C has same sign, then CB interval would be interval of interest where we can find the root, and we will end at a value, say P in AB, where the value of the function is 0. And this method guarantees that P will belong to A and B. So when this happens, we will end this method and P will be the root. Next, Newton-Raphson method, we will find the expression or the guess of root for the Newton-Raphson method using the tangent line passing through x naught and f of x naught. So this is the expression of the tangent line that passes through the given point. Here f dash of x naught is the slope, and with small manipulation, mathematical manipulation, we can get the expression for x1. So we can explain this f of this x1 graphically. X1 is the intercept of the slope of the function at f of x net, f of x naught. So this is the first guess of root. Then we can find the second guess of the root using the same procedure. And the second guess is called x2, and it is obtained with the help of x1. So this would be the second guess, and we can generate a sequence of such guesses to approach this root. So this is all about the Newton method. We have studied about the peak and fall of Newton-Raphson method. So from the graphs, you can have the idea when the slope is taking it away from the root, we will have no convergence when it oscillates, or when we have the initial guess which jumps away from the root, or when the slope is 0. In these cases, this is not a suitable method to use. So we have done an example. I am not going to detail of this example here. I'm just uh, teach you about the secant method. For the secant method, we will be using equation of secant line passing through x naught and f of x naught, x1 and f of x1. This will be the equation of secant line, and from here we will find a cut on the x-axis, a cut on the x-axis. So this cut can be found with the help of this equation, and it can be expressed in this form. Generally, this formula is may be written in this form: xk are the cuts, and these cuts will lead us to the root of the equation. We can explain it graphically as well. So graphically, I have x naught and x1. These are the 2 points. I draw a secant line over here, and this secant line cuts x is at x point 2. Then I draw a secant line from x1 and x2. It cuts the x-axis at x3. So I draw a secant line between x2 and x3, f of x2 and f of x3. It touches the x-axis at x4, and continuing this procedure, finally I'm going to get the root. So the next method is method of false position, regular falsy method. This method uses the same formula as we used in the secant method, but it includes an extra test to ensure that the root lies between the initial two guess or the initial two values. For example, I have x naught and x1 are the two values, and the function value, the product of the function value at x naught and x1 is less than 0, means f of x naught and f of x1 have opposite sign. I can calculate x2 with the help of secant method. Now the problem is how to compute x3. To compute x3, I have to check whether x2 and x1 are such that the function value at x2 and the function value at x1 has opposite sign. If this is the case, then the root will lie between x1 and x2, and I will choose x3 as intercept of the line joining x1 and f of x1 and x2 f of x2. But if it is not the case, means x1 f of x1 and f of x2 has the same sign, then I have to choose x naught and x2 to calculate x3. Means that we have to use recent value of x and some of the previous values of x which have opposite sign when used in the function. We can explain this fact or compare the false position method and secant position method as it is that initially we have xi and xi minus 1 are the 2 points. We draw a secant line, and where it touches x-axis, we have a guess of root. Then in case of false position, we have to ensure that one of these values f of x are in this case, and f of x I minus 1 must have opposite sign, and draw a secant line to get the new value of the root or new guess of the root. Whereas in secant method, we have to use the consecutive one recent and one previous value to get the new guess of the root, which may go mm, out of the interval containing that value xi and xi minus 1. Here we are solving an example. Basically, this is a comparison between secant method and method of false position. So you can see that to calculate x2, I have to use x1 and x naught. To calculate x3, I have to use x2 and x1. To calculate x4, I have to use x3 and x2 in the formula. Whereas in method of false position, to calculate x2, I have used x1 and x naught as I have used in the case of secant method. But to calculate x3, I have to see x2, f of x2 and f of x not. They have the opposite sign. Not x1 is used in this formula to ensure the opposite sign of f of x2 and f of x naught. So if these two have opposite sign, then the next guess will be calculated with the help of these two values, x naught and x2. So this is the difference between these two methods. Rest of the formula is the same. So we can do different iteration. So here I'm going to find the solution or the root of the equation x is equal to cos x in the given interval, and I have calculated this for three different methods. Uh, you can see that Newton-Raphson method is the efficient or the most efficient, and the iteration performed in case of false position are more than in case of secant method. So you can try different questions. I have given you these three problems, but you can try more questions. So at the end, I would like to um, give a brief summary of what we have studied. We have done the numeric nonlinear equation solving, and there are basically two methods, bracketing and open method. We can do it with the graphical method, but this is not important as far as the numerical method is concerned. So bracketing method or the bisection method and false position method, whereas the open method are the Newton-Raphson method and secant method. All these are the iterative methods, and as I mentioned, that we can use tolerance and error approximation to stop the algorithm or the stop working or of these methods. So if you have any comment or queries about these slides, you can email to me. Further, I have discussed some application of these in the electrical engineering, in the civil engineering, and there are other fields as well where these problems can be applied. But if you feel that you have any problem, you can email me. My email address is given here. So at the start of the lecture, I have written my email. So your questions are highly appreciated. And if you want to make any comment about the slide or the presentation, you are more than welcome to ask such question. Thank you very much.